Nodes are actually super powerful tools to make your creations even more awesome. In this video, we're going to break down nodes in a super simple way, no confusing jargon. We'll see how they're like building blocks that you connect to make amazing textures, materials, and effects for your 3D stuff. But before we begin, let me introduce you to ThreeDee.design, your world of captivating 3D character models, icons, and more. Here you can find a lot of premium 3D packages along with avatars and fancy cars. Plus, our 3D models work with any type of design tools such as After Effects, Photoshop, Figma, Blender, Premiere Pro, and many more. Start your creative journey here for an immersive experience. Alright, so let's begin with the video. Blender has divided its 80+ material nodes into 8 different groups. So let's start off with input nodes. The Ambient Occlusion node simulates how light is blocked or occluded by surrounding objects, enhancing the realism of shadows and giving a more detailed look to the crevices and nooks of 3D models. It darkens areas where objects are close together, adding depth and texture to the scene. The Attribute node is used to access and use custom data from your mesh, like colors, UV maps, or vertex groups within the shader network. It lets you incorporate specific mesh attributes into your materials for more detailed and customized effects. The Bevel Node creates a subtle rounding effect on the edges of 3D models within the shader, simulating the look of beveled edges without altering the actual geometry. This helps to add realism by softening hard edges and catching light more naturally. The Camera Data node provides information about the camera's position, direction, and settings. This data can be used to create effects that depend on the camera's view, like depth of field or perspective-based shading adjustments. The Fresnel Node calculates how much light is reflected versus refracted based on the viewing angle, simulating the way surfaces appear more reflective at glancing angles. This effect is commonly used to enhance the realism of materials like glass, water, and shiny surfaces. The Geometry node provides information about an object's shape and position, such as its normals, position, and texture coordinates. This data can be used to create effects that react to the object's geometry, like procedural textures and shading variations. The Curve Info node provides information about a curve's properties, such as its position along the curve and the shape's normals. This data helps create effects that depend on the curve's form, like varying thickness or color along the curve. The Layer Weight node calculates the angle between the surface and the viewing direction, providing outputs for Fresnel and facing effects. It's used to blend materials and create realistic shading effects that change based on the viewing angle. The Light Path node provides information about the path of light rays in a scene, such as whether a ray is direct, reflective, or refractive. This helps create advanced shading effects like transparency, reflections, and shadows based on the light's interactions with objects. The Object Info node provides data about the object itself, including its location, rotation, and scale. This information can be used to create procedural effects and textures that respond to the object's properties, such as its position in the scene or its unique identifier. The Particle Info node provides information about particles emitted from objects, such as their age, velocity, and location. This data is useful for creating effects that interact with particles, such as changing colors or sizes based on particle properties. The Point Info node provides information about individual points in a geometry, such as their position, color, and index. This data is useful for creating effects that depend on the characteristics of each point, such as custom shading or procedural manipulation. The RGB node allows you to define a color using red, green, and blue channels. It's a fundamental tool for specifying colors within materials and textures, providing precise control over the appearance of objects in your scene. The Tangent node provides information about the tangent direction of a surface at each point. This data is essential for creating effects like bump mapping or controlling the orientation of textures based on the surface's geometry. The Texture Coordinate node provides various coordinates used for mapping textures onto objects. These include options like UV, generated, object, or camera coordinates, allowing you to control how textures are applied and manipulated across different surfaces in your scene. The UV Map node retrieves the UV coordinates of a mesh, which define how textures are applied to its surface. It's crucial for accurately mapping textures onto objects, ensuring that textures align correctly and appear as intended in the final render. The Value node allows you to input a single numeric value, such as a grayscale intensity or a numerical parameter. It's often used to control properties like material brightness, transparency, or any other numerical attribute in your scene. The Color Attribute node retrieves color information from the attributes of objects, such as vertex colors or custom attributes. It enables you to manipulate and use these colors within the shader network, allowing for custom shading effects based on object-specific color data. The Volume Info node provides information about the volume of a shader, such as the density or depth within a volumetric object. It's used to create effects like controlling the density or color of volumetric shaders based on the position or properties within the volume. The Wireframe node generates wireframe-like patterns based on the geometry of an object. It's often used for stylized effects or to create wireframe renders, showing the underlying structure of the object by outlining its edges. The Arbitrary Output Variable node allows you to output specific render passes or data channels as separate image files. This is useful for post-processing tasks, compositing, or fine-tuning individual elements of the render, such as shadows, reflections, or object IDs. The Material node defines the surface appearance of an object, specifying its color, reflectivity, transparency, and other visual properties. It serves as the building block for creating realistic or stylized materials within Blender's shading system. The Light node represents a light source in the scene, emitting illumination to illuminate objects and surfaces. By adjusting its properties such as intensity, color, and falloff, you control how light interacts with your scene, influencing the overall look and atmosphere of your renders. The World node defines the environment surrounding your scene, including the background, color, lighting, and effects like HDR environments. By adjusting its settings, you control the ambience and appearance of the world your objects inhabit, affecting the overall mood and realism of your renders. The Edge Shader node combines the shading of two different shaders together, resulting in a final combined appearance. It's useful for mixing different material properties or textures to achieve complex surface effects in your renders. The Background node represents the color or image that appears behind your 3D scene. It's commonly used to set the backdrop for your renders, providing context or atmosphere to your scene's environment. The Diffuse BSDF node defines how light scatters or spreads across a surface uniformly, simulating matte or non-shiny materials like paper or fabric. It's essential for creating realistic lighting and shading effects in your materials. The Emission node emits light from the surface it's applied to, making the object appear as if it's glowing. It's useful for creating light sources within your scene, such as lamps or neon signs, or for adding special effects like glowing objects or materials. The Glass BSDF node simulates the behavior of transparent and reflective surfaces, like glass or water. It combines both reflection and refraction properties, allowing light to pass through while also reflecting the surrounding environment, creating realistic glass-like materials. The Glossy BSDF node mimics the appearance of smooth and reflective surfaces, such as polished metal or shiny plastics. It controls how light reflects off the surface, producing sharp highlights and specular reflections, adding realism to materials with a glossy finish. The Hair BSDF node is tailored for simulating the appearance of hair strands or fur in materials. It allows for controlling the color, reflectivity, and shading of individual hairs, enhancing the realism of hair and fur materials in rendered scenes. The Holdout node acts as a mask, making the object it's applied to transparent in the render, revealing the background behind it. It's useful for compositing by allowing you to isolate specific objects or areas in your scene, making them transparent to incorporate other elements seamlessly. The Mix Shader node combines two different shaders based on a specified blending factor, creating a smooth transition between them. It's useful for blending materials with different properties, such as combining diffuse and glossy shaders for realistic surface appearances. The Principled BSDF node is a versatile shader that combines multiple material properties into a single node, simplifying the process of creating realistic materials. It includes controls for base color, roughness, metallic, specular, normal maps, and more, allowing for intuitive and efficient material creation. The Principled Hair BSDF node in Blender is designed for rendering realistic hair and fur, providing controls for color, roughness, and scattering. It simplifies the creation of natural-looking hair materials by integrating multiple hair shading properties into one easy-to-use shader. The Principled Volume node is a shader designed specifically for volumetric materials, such as smoke, fog, or clouds. It provides intuitive controls for adjusting density, anisotropy, emission, and scattering, allowing you to create realistic volumetric effects with ease. The Refraction BSDF node simulates the bending of light as it passes through transparent surfaces, like glass or water. It controls how light is refracted or bent, affecting the appearance of materials with transparency, and creating realistic optical effects. The Specular BSDF node simulates the specular highlights on surfaces, representing the reflection of light sources. It's used to control the intensity and color of these highlights, adding shine and glossiness to materials for a more realistic appearance. The Subsurface Scattering node simulates the behavior of light as it penetrates and scatters within translucent materials like skin or wax. It controls how light interacts with the material's subsurface layers, producing a soft and realistic effect, particularly noticeable in materials with translucency. The Toon BSDF node in Blender creates a stylized shading effect similar to traditional cell shading, with flat, solid colors and sharp edges. It's useful for achieving a cartoon or comic book-like appearance in your renders, providing a simple and distinctive visual style. The Translucent BSDF node simulates the scattering of light through semi-transparent surfaces, like frosted glass or thin fabric. It controls how light is diffused and transmitted through the material, creating a soft and diffuse appearance with some level of transparency. The Transparent BSDF node simulates completely transparent materials, allowing light to pass through them without any distortion or scattering. It's useful for creating materials like glass or clear plastic, where objects behind the material are visible. The Sheen BSDF node simulates the soft, velvety appearance seen on certain surfaces when light reflects off them at shallow angles. It adds a subtle, satin-like effect to materials, enhancing their realism by mimicking the way light interacts with soft surfaces. The Volume Absorption node controls how light is absorbed as it travels through a volumetric material, like fog or smoke. It allows you to specify the color and density of the medium, affecting the appearance of the volumetric effects in your scene. The Volume Scatter node simulates the scattering of light within a volumetric material, such as fog, smoke, or clouds. It controls how light interacts with the particles in the volume, creating realistic effects like soft illumination and atmospheric haze. The Brick Texture node generates a procedural texture resembling a pattern of bricks, with adjustable parameters for size, color, and mortar thickness. It's useful for quickly creating brick-like surfaces without the need for external textures, ideal for architectural renders or stylized environments. The Checker Texture node generates a procedural texture featuring a repeating pattern of squares, with options to adjust the size, color, and contrast. It's commonly used for creating simple textures like tiles, grids, or patterns for various materials in your scene. The Environment Texture node is used to load and display 360-degree panoramic images, like HDRIs, to simulate real-world lighting and reflections in your scene. It provides a background image that surrounds your objects, enhancing realism and adding depth to your renders. The Gradient Texture node generates a smooth transition between colors, typically along a linear or radial direction. It's useful for creating gradient effects such as color ramps, smooth shading transitions, or procedural textures with varying colors. The IES Texture Node is used to import and use IES files, which contain photometric data describing real-world light distribution patterns. It's useful for accurately simulating the lighting behavior of specific light fixtures or lamps in architectural visualizations or product renders. The Image Texture Node imports and uses image files, like JPEGs or PNGs, as textures for objects in your scene. It allows you to apply detailed textures to surfaces, such as wood grain, fabric patterns, or photographs, enhancing realism and adding visual interest to your renders. The Magic Texture Node generates a procedurally generated texture with an appearance resembling magical or mystical patterns. It's versatile for creating fantasy-themed materials or adding intricate details to surfaces in your scenes. The Noise Texture Node generates random variations in color or value, creating a rough, grainy effect. It's commonly used for adding texture to materials like rough surfaces, dirt, or procedural patterns, enhancing realism and detail in your renders. The Point Density Node calculates the density of points within a volume based on their proximity, allowing you to create effects like clouds, fire, or particle systems that change density over space. It's useful for generating volumetric effects with varying densities, adding detail and realism to your scenes. The Sky Texture Node generates a procedural sky background, simulating the appearance of the sky at different times of the day and under various weather conditions. It provides options for adjusting parameters like sun position, horizon color, and cloud coverage, allowing you to create realistic outdoor environments for your scenes. The Voronoi Texture Node generates a pattern of cells, each containing a point, based on a set of input parameters. It's commonly used for creating textures resembling cracked surfaces, irregular patterns, or procedural noise, adding detail and complexity to materials in your scene. The Wave Texture Node creates a repeating pattern resembling waves, with adjustable parameters for frequency, amplitude, and direction. It's useful for generating textures resembling water ripples, wood grain, or other wavy patterns, adding visual interest and detail to your materials. The White Noise Texture Node generates random variations in color or value with equal energy at all frequencies, creating a smooth, random pattern. It's commonly used for adding subtle texture or procedural randomness to materials, enhancing realism and detail in your renders. The Brightness Contrast Node adjusts the brightness and contrast of an input image or texture. It allows you to make images lighter or darker and increase or decrease the difference between light and dark areas, providing control over the overall appearance of your textures or renders. The Gamma Node adjusts the gamma correction of an image, controlling its overall brightness and contrast. It's useful for fine-tuning the appearance of textures or renders, ensuring accurate color reproduction and proper display on different devices. The Hue Saturation Value Node allows you to adjust the hue, saturation, and value of an input color. It's useful for modifying the color properties of textures or materials, enabling you to change their appearance without altering their underlying structure. The Invert Color Node reverses the color of an input image or texture, turning light areas dark and vice versa. It's handy for creating negative effects or inverting specific color channels within your materials or textures. The Light Falloff Node simulates how light intensity diminishes as it travels further from its source. It's used to control how light spreads and fades across a scene, influencing the overall lighting and mood of your renders. The Mix Node blends two input values together based on a specified factor, creating a smooth transition between them. It's versatile for combining different shaders, colors, or textures in your materials, allowing for various blending effects and adjustments in your renders. RGB Curves Node adjusts the color and brightness of an image by modifying the red, green, and blue color channels individually. It's useful for fine-tuning the color balance, contrast, and overall appearance of textures or renders, providing precise control over the color grading process. The Bump node simulates surface detail by perturbing normals based on a texture input, creating the illusion of bumps and dents on surfaces without altering geometry. It's used to add depth and realism to materials, enhancing their appearance by mimicking small-scale surface variations. The Displacement node physically deforms geometry based on a texture input, altering the shape of surfaces to create detailed relief effects. It's useful for adding large-scale surface variations like bumps, wrinkles, or terrain features to objects, enhancing their realism in renders. The Mapping node controls the mapping of textures onto objects, allowing you to adjust their scale, rotation, and position. It's useful for precisely positioning textures on surfaces, ensuring they align correctly and appear as intended in your renders. The Normal node modifies surface normals, affecting how light interacts with geometry and influencing shading. It's used to create intricate surface details by adjusting the direction of light reflection, adding realism and depth to materials without altering the underlying geometry. The Normal Map node alters surface normals based on an input image, simulating intricate surface details without adding geometry. It's commonly used for adding high-frequency details like bumps, wrinkles, or texture variations to objects, enhancing their realism in renders. The Vector Curves node adjusts the direction or magnitude of vector values, such as normals or texture coordinates, using customizable curves. It's useful for controlling the flow of textures or modifying surface normals, allowing for precise adjustments to surface appearance and shading. The Vector Displacement node deforms geometry based on a vector input, allowing for intricate surface details like bumps or dents. It's used to modify the position of vertices in a mesh, creating complex surface variations for added realism in renders. The Vector Rotate node rotates vector inputs, such as normals or texture coordinates, around a specified axis. It's useful for orienting textures or modifying surface normals, allowing for precise control over the direction of surface details or shading effects. The Vector Transform node alters vector inputs, such as normals or texture coordinates, using transformation matrices. It's useful for translating, rotating, or scaling vectors, allowing for precise control over texture mapping or surface orientation in your materials. The Blackbody node generates colors based on temperature values, simulating the appearance of heated objects like incandescent light bulbs or glowing metal. It's useful for creating realistic emissive materials with accurate color temperatures, enhancing the realism of your renders. The Clamp node limits input values to a specified range, preventing them from exceeding certain thresholds. It's useful for controlling the output of nodes, ensuring that values stay within desired limits to avoid unexpected results in shaders or compositing. The Color Ramp node remaps input values to different output colors, allowing for precise control over gradients and color transitions. It's commonly used for adjusting the appearance of textures, controlling shading effects, or creating custom color variations in materials. The Combine Color node in Blender merges separate red, green, and blue color inputs into a single RGB color output. It's useful for creating custom colors by combining different color components, enabling precise control over the appearance of materials and textures. The Combine XYZ node in Blender merges separate X, Y, and Z vector inputs into a single 3D vector output. It's useful for creating custom vectors by combining different components, allowing for precise control over transformations, texture mapping, and shading effects in your scenes. The Float Curve node adjusts float values based on a customizable curve, allowing for precise control over the mapping of input values to output values. It's useful for shaping the behavior of parameters in shaders or compositing, enabling fine-tuning of effects and visual elements in your renders. The Map Range node remaps input values from one range to another, allowing for flexible control over the distribution and scaling of values. It's useful for adjusting parameters such as brightness, contrast, or scale, ensuring that values are mapped to desired ranges for optimal visual results. The Math node performs mathematical operations on input values, such as addition, subtraction, multiplication, or division. It's useful for creating complex procedural effects, controlling material properties, or manipulating data within your node network. The mix node blends two input values together based on a specified factor, creating a smooth transition between them. It's versatile for combining different shaders, colors, or textures in your materials, allowing for various blending effects and adjustments in your renders. The RGB to black and white node converts a color image into a grayscale image by averaging the intensity of its red, green, and blue channels. It's useful for simplifying images or textures to focus on their luminance values or for creating monochromatic effects in your materials or renders. The separate color node splits a color input into its individual red, green, and blue channels. It's useful for isolating and adjusting specific color components within your node network, allowing for precise control over color manipulation in materials or textures. The separate XYZ node splits a vector input into its individual X, Y, and Z components. It's useful for isolating and controlling each component separately within your node network, allowing for precise adjustments in transformations or texture mapping. The shader tool. RGB node converts shader information, like surface color or emission, into RGB color values. It's useful for extracting shading data and incorporating it into your node network for further processing or compositing effects in your renders. The vector math node performs mathematical operations on vector inputs, such as addition, subtraction, or multiplication. It's useful for combining, manipulating, or transforming vector values within your node network, enabling various effects and adjustments in your renders. The Wavelength Node generates a color based on a specified wavelength, simulating the color of light corresponding to that wavelength. It's useful for creating accurate spectral colors or for simulating the appearance of light sources with specific wavelengths in your renders. The Group Input Node serves as the entry point for data into a node group, allowing you to define input parameters that can be controlled externally. It's useful for creating flexible and reusable node groups by enabling customization of parameters from outside the group. The Group Output Node serves as the exit point for data from a node group, allowing you to define output values that can be accessed externally. It's useful for creating modular and reusable node groups by providing a way to retrieve computed results from within the group. So that brings us to the end of this journey. If you find this video helpful, consider subscribing and giving this a big thumbs up. Don't forget to check out our vast library of 3D character models at 3D.design. And I'll see you in the next one. Thanks.